Have you ever just looked around and felt that the rules of our reality are a little strange? Well, welcome. Today, we're going to embark on a pretty unique thought experiment. We're going to try and decipher the source code of the universe itself.
And that really gets us to the heart of it, doesn't it? It's the one question that has been bugging physicists and philosophers for, well, forever. Why? Why is our universe built on a set of rules that so often just completely defy our everyday common sense?
Okay, let's really get into this. Modern physics has shown us a world that is just profoundly weird. I mean, take quantum mechanics. Why on earth does a particle's behavior totally flit the instant we decide to look at it? Or what about relativity? Why does time literally slow down when you get near a massive object? Are these just cosmic glitches? Bugs in the system? Or could there be a deeply rational, even elegant reason behind it all?
To even begin to find an answer, we have to completely change how we're looking at the problem. So let's try something a little radical. What if this world is a game?
So in our thought experiment, the universe runs just like a massive online game. You've got a central server that manages the true, objective state of everything, making sure it all stays consistent. And then you have the client, which for our purposes is our consciousness, that just receives the rendered information from that server. Now, let's be super clear here. This is an analogy. It's not a physical truth. It's a new lens, a new way to maybe make sense of a very complex reality.
So with this whole game idea in our back pocket, let's see if we can start to unlock the code. We're going to start by looking at the rules that seem to govern information in our universe.
This reframes quantum mechanics in, well, a fascinating way. You know that weirdness where a particle's state isn't decided until you look at it? In our model, that's just lazy evaluation. The server isn't going to waste precious resources calculating everything all the time. No way! It only renders the final state when a player, that's us, actually observes it. It's a brilliant way to cut down on the computational load. And all the randomness we see at the quantum level? That's the ultimate anti-cheat system, making sure nobody can perfectly predict and manipulate the future. It keeps the game fair.
And that brings us to one of the biggest mysteries in all of physics, quantum entanglement. Einstein famously called it spooky action at a distance. So you have two particles that are linked in this fundamental way. If you measure one, you instantly know the state of the other one, even if it's on the opposite side of the galaxy. How is that even possible?
This right here is where our game analogy becomes incredibly powerful. Those particles aren't sending signals faster than light. That's impossible. Instead, just think of them as two desktop shortcuts that point to the exact same file on the server. If you change the file using one shortcut, the other one reflects that change instantly, right? Not because they talk to each other, but because they both just point to the same piece of data. That's why the correlation can ignore distance, but actual communication can't.
Any good game needs rules for managing its resources. And in our universe, the most fundamental rule is the conservation of energy. You can't create it, you can't destroy it, you can only change its form. In game terms, this is a non-negotiable rule to stop players from just creating infinite resources out of thin air, which would obviously crash the whole system. Every action has to have a cost. This is the bedrock of stability.
But what about time? We all feel it. We move forward into the future, but we can never go back. We remember the past, but not the future. What's the deal with that? Why does an egg break, but it never, ever spontaneously unbreaks itself?
Well, the answer seems to be entropy, the universe's steady march toward disorder. But from a data point of view, this is basically a storage solution. I mean, just imagine the server trying to store the exact state of every single particle throughout all of history. The amount of data would be impossible. So what does it do? The server performs an irreversible log compression on past events. It keeps the result, the broken egg, but it throws away all the super detailed data about how every single molecule got there. We can't go back in time because the data we need to restore that past state, it's been deleted to save space.
Okay, so what about the most extreme things in the universe, black holes? In our model, they're not just cosmic vacuum cleaners. They are the universe's garbage collector. They take in all this potentially unstable, high-density information, stars, planets, you name it, and they neatly wall it off from the rest of the system. And all of that incredible complexity gets summarized, and it's represented by just three simple numbers on the outside: mass, charge, and angular momentum. It is the ultimate tool for data summarization and system stability.
All right, so we've looked at the rules of information. Now let's dig into the actual fabric of the game world itself, the rules of space-time.
So, imagine you're a programmer, and you have to code gravity for a simulated universe. How would you do it?
Well, the brute force way would be to calculate the gravitational pull between every single particle and every other single particle, constantly. The amount of processing power that would take is, well, it's unimaginable. It would crash any server instantly. So a smart designer would look for a much more elegant solution.
And that elegant solution is general relativity. The server doesn't even bother with trillions and trillions of individual force calculations. Instead, it just rewrites the rules of the game map itself. It literally curves space-time around objects with mass. So now, objects aren't being pulled by some mysterious force. They're simply following the straightest possible path through a curved environment. It's an absolutely breathtaking optimization engine.
This also beautifully explains time dilation. Why does time slow down in a strong gravitational field? Well, think of it like a server's performance monitor. An area with a lot of mass, like near a planet or a black hole, is a high-load zone. It requires a ton of computation. So to prevent a system crash, the server deliberately lowers the system clock speed, what we experience as the flow of time in that specific area. It's actually a standard technique in computing to maintain stability.
So where do we fit into all this? Well, our consciousness, in this model, is basically the client's user interface. We are experiencing a world that has been rendered for us by the server. But here's the catch. Just like any network, there's lag. The now that you're experiencing at this very moment is actually a reconstruction in your brain of information that was finalized on the server a fraction of a second ago. We're all living just slightly in the past. So let's bring all these different threads together. When we look at the universe through this particular lens, all of those bugs and strange rules, they start to look less like flaws and a lot more like features.
Suddenly, quantum theory is load reduction and an anti-cheat system. Gravity is a powerful optimization engine. Entropy and black holes, that's just data management and garbage collection. Time dilation is just CPU clock control, and our own consciousness is the user interface. All at once, the strange and baffling rules of physics start to look like a surprisingly rational, deeply interconnected set of principles for running a massive, stable, and incredibly efficient information system. It's an elegant design.
But all of this leads us to the most important question we can ask. Is this the truth, or is it just a story?
And the answer, just like we said at the very beginning, is that this is a story. It's a thought experiment. Its real value isn't in whether it's literally true or false. Its power is in giving us a new, intuitive way to grasp some of the most mind-bending concepts in physics. It's a way to spark our curiosity about the very nature of reality. It's a tool for thought.
So I'll just leave you with this final thought. After exploring the universe as one massive, elegant game, has your view of the world changed, even just a little?